8.2, adding and subtracting rational expressions. We're going to start by finding the least common multiple. I think it helps to factor out the numbers. This 15 is 3 times 5. But really, all we're trying to do is make a match, all right? I've got some stuff on the left side and some stuff on the right side. We need them both to be the same. And so when I look at the right side, it needs a 5. Now both of them have a 3 and a 5, all right? When I look at the x numbers, this one has x to the third. This one only has x to the second, so I'm going to give this one an x. And you look at the y's, this one has y to the fourth. This one needs 2 more y's, okay? So if you put everything together, now they're all the same, all right? So both of them have a 3 and a 5 and 3 x's and 4 y's. So this LCM is going to be 15, 3 times 5, and x to the third, y to the fourth. That's what they both have in common. That's the smallest thing that they could both have in common. If you look at number 2, it's a little bit harder to see what to do, I think, but that's because you're going to have to factor. We want to look at factors, not things that are added, but things that are multiplied. And so here on the left side, we see an easy trinomial. Two numbers that multiply to 12 and add up to 7, plus 4, and plus 3. And so on the left side, once you get it factored, you can see that there's a factor of x plus 4 and a factor of x plus 3. Now on the right side is a GCF pattern, and both of those numbers are divisible by 4. So if you remove that 4, if you pull out that 4, you'd be left with x plus 3. So keep in mind, you're looking for what's in common, or you want to have what's in common. And so on the right side, it'd be nice if they had an x plus 4. Now they're almost the same, but on the left side, let's give that thing just a plain old 4. Once you get them the same, that's it. That's the answer. So the LCM is 4 times x plus 4, excuse me, times x plus 3, LCM. That's what it's going to take for the hardest problems in this section. Essentially, when we're adding and subtracting rational expressions, we're just adding and subtracting fractions. So in a problem like number 3, when you've got the denominator is already the same, then you just add. We already know the denominator is whatever this is, 6x to the 5th y. On the top, we combine like terms. I see x plus x is 2x. And 6y plus negative y is plus 5y. There's nothing else we can really do. You can't cancel. Somebody's going to say, but can you reduce the 2 and the 6? Well, no, you can't, because that 2 is not a factor. 2 is a part of a binomial. That's the answer. That's all you can do. Let's look at number 3. Okay, great. The denominator is the same. So then we know the denominator is this, 4 times k minus 6. So just do k minus k. That's going to cancel out. And 6 minus 6, oh, that's 0. This answer is just going to reduce to 0. Everything cancels out. Number 7, common denominator already. Perfect. 24a cubed b. Look at your like terms. A plus a is 2a. 4b plus 4b is plus 8b. Now, it's hard to tell, but this one has something that can reduce. And it's because the top has a GCF. On the top, these two numbers are divisible by 2. And so if I take out a 2, I would have a plus 4b. All right. Now that 2 is a factor, I can reduce 2 into 24, and that's 12. That's reduced. A plus 4b over 12a cubed b. Number 9. Again, common denominator, so that makes this one not so bad. It's a lot harder when the denominator is not the same. U plus U is 2U. Negative 2V plus 6V is plus 4V. I have a common denominator of 2. I mean a common multiple, a common factor, I should say. But that 2 doesn't reduce, so it doesn't really help us to factor this. It doesn't hurt us though. We could write it like this, and that could be right. That's a 2. Or this. They're both the same. Doesn't really matter. Number 11, common denominator. Okay, great. So if it's a common denominator, we can go ahead and combine them. 3x plus x is 4x. 3 plus minus 4 is minus 1. There's nothing to factor. There's nothing to cancel. That's all there is to it. That's your answer. Right. Now the fun part. On the back, it's a lot harder when they're not the same. You can't just say 2 plus 6 is 8 and start sticking stuff together. That's not how it works. You have to make them the same. All right. So, what number is going to make the one on the left into a 6? Well, we're definitely going to need a 3. So you're going to give the one on the left a 3 so that we can make them both 6. Now they both have a 6. 3 times 2 is 6. They both have a 6, but you have to do top and bottom. We're multiplying by 1 after all. But if you look at the left side and the right side, notice how this one has x squared. We're going to need to give this one x squared. So you need to do whatever you need to do to make the two denominators the same. And I would probably skip this part, but let's clean up. On the top here, I've got 3 times 5 is 15, x cubed. On the bottom, 3 times 2 is 6, x squared y. Plus over here, I didn't really do anything to it. I've got this. We've got a common denominator. So we can add them, put them together into a single fraction. And this is not like terms with this. You can't combine and say 15 plus 4 is 19. They're not like terms. One of them has an x, one of them has an x cubed. So the best we can do here is just write them down. 15x cubed plus 4x. There were no like terms. What we do have, though, excuse me, is a common factor there. All right, we've got an x in common, so we could take that out. So one of the x's can cancel there, x with one of those x's. And I'm left with 15x squared plus 4 over 6xy. Yep. Isn't it though? 15. Okay. I don't know. Is this weird? Think about it as this is a binomial and this is a binomial. What you need to do is say, well, the one on the left needs a 2x minus 3. And the one on the right needs an x minus 1. So now the denominator is just both of those things. The denominator is 2x minus 3 times x minus 1. Once you get the denominator the same, write it down. That's the common denominator. Other than that, though, we need to clean this up quite a bit. And so I'm going to distribute. That is multiplication, by the way. I'm going to distribute right there. That's 4x squared minus 6x. And then I'm going to distribute, but you've got to pay attention. That's not a 3, that's a minus 3. So I'm going to distribute the subtraction as well. I'm thinking of subtract 3 as a minus 3. So if I distribute that, I'll have minus 3x plus 3. And so combine like terms. The only like terms are minus 6x minus 3x is minus 9x. I've got 4x squared minus 9x plus 3. Next problem is basically the same idea, 17. I've got a 3x minus 1. This one's going to need an x plus 3. I've got an x plus 3, and this one's going to need a 3x minus 1. We're just trying to make them the same. We have to make them the same because we couldn't add them otherwise. They have to have a common denominator. They have to be like terms, basically. So once you make them the same, I know the denominator is going to be 3x minus 1 times x plus 3. Other than that, we've got a lot of stuff to clean up on the top. The top is the hard part. We distribute here, that's 6x plus 18. And notice this is a plus sign, so that makes it a little bit easier. We're distributing a positive 2. That's going to be plus 6x minus 2. You've got to pay attention to that plus sign right there. So like terms, I've got 6x plus 6x is 12x. And 18 minus 2 is plus 16. I think the hardest part of this is recognizing when you need to factor. I see a GCF here, and that GCF is 4. If you factor out that 4, you're going to be left with 3x plus 4. And so you've got to do that because sometimes you're going to be able to cancel that piece of that. You might be able to reduce after that. In this case, I didn't need to. And what kind of stinks is you don't need to reduce if you don't need to reduce, but sometimes you can't tell if you need to until after you do this factoring. So the fact that we didn't need to reduce means we didn't really need to do the factoring. So either way you want to write the answer, might as well just write it in the factored form since we've already got it. But in this case, we didn't really need to do that step. Sometimes you do, sometimes you don't. I think that makes this a little bit harder. All right. So the next one, I'll tell you what, if you can reduce, it's gonna make your numbers a little bit easier. So notice how 3/6 is 1/2. That'll just make your numbers smaller, and you don't necessarily have to do that in the first step, but a lot of the times it will help. The other one, 4k minus 6, has a GCF, but that doesn't really help me. And so really, if it doesn't help you, you kind of don't want to do it. But here we go. Let's make them the same. The one on the left needs denominator 2. The one on the right needs a 3k plus 2. They're all kind of the same. Let's give that denominator. There's a 2 and there's a 3k plus 2. Top left, I'd distribute right there. That's 8k minus 12. And then we're distributing a plus 1. So it's just going to be 3k plus 2. So let's combine our like terms. 8k and 3k make 11k. Negative 12 plus 2 is minus 10. Last thing you want to do is just check if you can factor. If you can factor, sometimes you can cancel, sometimes you can reduce. In this case, there's nothing to reduce or cancel. We're leaving it alone. 21. I see a couple of things that I can reduce right off the bat that might make this easier. See how those 6's would knock out? That's going to reduce to just 1 over v. I see one other thing. I see this fraction right here, 6 over 4 would reduce to 3 over 2. So I don't know that you need to rewrite this, but maybe it would help. 3u over 2 plus 1 over v. You don't need to do that if you can see it out of the problem. But this problem is much easier, I think, than some of the others because it's very straightforward. This one needs a v, and this one needs a 2. Denominator is just going to be 2v. The numerator, this is 3vu, or uv, it doesn't really matter. And then this is 2. That's it. You can't reduce those 2's because you can't reduce something that's being added. You can only reduce factors. Bless you. That's your answer. Next one, I see a few things that can reduce here. First of all, those 2's knock out. This m can cancel one of these m's, so there'd just be 2 of them left on the bottom. This 6 over 4 reduces to 3 over 2 again. And so let's clean this up. That's 3 over 2m minus, that would be 1 over m squared. Okay. So basically, make sure you keep it as small as possible. I want to do the least common multiple. This one has a couple of m's. I just need to give this one another m. Now they both have m squared. Now they both have a couple of m's, right? And the one on the right needs a 2, so I'm going to give it a 2. Now they both have 2m squared. That's the whole point. Let's get a common denominator. Now we've got a common denominator, 2m squared. So now I know my denominator is 2m squared. What do I have on the top? That's just going to be 3m minus 2. Last one. Okay, so this one's maybe a little bit harder because it's going to require some factoring. And notice there's a common factor. When we factor, we always look for a common factor first. So I see a 3. R squared minus 5r minus 6. All right, that was a GCF. Always look for that first. Otherwise, you're doing a hard trinomial when you don't need to do a hard trinomial. Next, I see a easy trinomial. Easy trinomial right here. So you're going to have this 3, but we're also going to have an r and an r. Two numbers multiplied is 6. Sometimes people miss it when it's this one. I need two numbers to multiply to negative 6 and add up to negative 5. What was that, plus 1 and minus 6? So plus 1 and minus 6. That's my denominator. So both of them have a 3. The left side has a 3, the right side has a 3. But the left side doesn't have all the r business, okay? So notice how the left side is going to need an r plus 1 and an r minus 6. It's probably going to be easier if you treat it like r squared minus 5r minus 6. You're going to end up having to distribute, so we might as well use this form instead of the factored form. Now they both have a 3 and an r plus 1 and an r minus 6. They're both the same. All right, they're both the same. So I know that common denominator is 3 times r, well, I guess let's just leave it as the factored form. That way, if anything needs canceled later, we're all ready to go. There's a 3, and there's an r plus 1, and there's an r minus 6. So then let's distribute right here. We'd have 2r cubed minus 10r squared minus 12r. And then don't forget, you're going to have the plus 2. So I'm looking at 2r cubed minus 10r squared minus 12r plus 2. I see a GCF, but I don't know that that's going to help. There is something called factor by grouping, but I don't know that I want to get into that. Let's just call it right here.